In a monolithic application, implementing transactions is not very difficult, especially with Spring Framework support. We start a transaction, we perform a set of business operations, and then transaction ends. If any of these steps within a single transaction is not successful, then we can throw an exception, and then all the database modifications that we have done are rolled back. It is all or nothing ACID transaction, and within a single application, it is relatively simple to implement. Now, let's review some of the properties of ACID transaction that we use in monolithic application. The first letter in the ACID acronym stands for atomacy or atomic. ACID transactions are atomic, which means that all operations are executed successfully or everything fails together. The second letter in ACID acronym stands for consistency, which means that the data is in a consistent and a valid state when a transaction starts and when transaction ends. A very common example of it is with the two bank accounts. If you need to transfer funds from one account to another account, then the consistency property means that the total value of funds in both accounts is the same at the start of a transaction and at the end of the transaction. Once transaction has ended, the data in the database should be valid and there should be no half-done updates. The next letter starts for isolation, which means that another transaction that is running concurrently cannot access the intermediate state of another transaction. And the last letter in ACID acronym stands for durability, which means that after transaction is done, the changes in the database are stored durably. If an error or system failure takes place after transaction is done, then the changes made within this transaction will not be reverted. In microservices architecture, where each microservice is a separate application with its own database, executing ACID transactions is much more challenging. It is no longer a single application. Microservices run on different servers and they communicate with each other over HTTP, and there is now no single database to work with. Each microservice works with its own database. So to perform a transaction that places a new order in our system, multiple microservices will need to communicate with each other. For example, a customer places an order, and the order microservice receives a request and creates a new order. The order microservice will make a new record into its own database, and if all is good, it will send a request to a products microservice to reserve the selected product in stock. Products microservice will update its own database to reserve the product in stock. And if this operation is also successful, then a request to users microservice to fetch user payment details will be sent. Now, hopefully this operation will also be successful, and if it is, then a request to process payment details will be sent. If this operation fails, then the flow ends. The order placement operation is not successful, and we ended up with multiple databases in an inconsistent state. We have an open order record in the orders database, and we have a reserved product in the products database. The product was not purchased, and it is not available for other customers to purchase as well because it is booked. To fix the situation, we need to implement transaction rollback. And this transaction will need to take place between multiple microservices, and there are risks. For example, products microservice might fail, and we end up with a system that has data in an invalid state. To be able to build business logic that is distributed across multiple microservices and to achieve data consistency across these distributed microservices, we can use a design pattern that is called Saga. The Saga design pattern is a way to manage data consistency across microservices in distributed transaction scenarios. And there are two different ways to implement Saga design pattern. One way is called choreography-based Saga, and another way is orchestration-based Saga. And in the following video lessons, we will have a look at each one of them.